Welcome to ClickMyProject.com. The title is Universal Fairness Evaluation Framework for Resource Allocation in Cloud Computing. Now we discuss about abstract. In cloud computing, fairness is one of the most significant indicator to evaluate the resource allocating algorithm. So which reveals whether each user is allocated as much that of the other users having the same bottleneck. However, fair and allocation algorithm is remaining an urgent issue. In this paper, we propose the dynamic evaluations framework for fairness. So that means DEFF, a framework to evaluate the fairness of a resource allocation algorithm. In our framework, two submodules: dynamic demand and then dynamic noted. So, and then I propose to describe the dynamic characteristics of resource demand and the computing node number under cloud computing environment. So, computing fairness and domain star and two submodules above. We finally obtain the DEFF. In our experiment, we adopt the several typical resource allocations algorithm to prove the efficiency and fairness evaluations and using DEFF framework. So we evaluate the effectiveness DEFF model firstly to prove the efficiency using DEFF and fairness evaluations. We adopt the DARF max minimum algorithm examples in our experiment. Then we adopt the utility based on algorithms and so as effectiveness evaluating fairness variations by using DEFF. Then adjust the factor. Proportional fairness is also utility based on algorithms similar with the fairness we take in our experimental DEFF so that difference of fairness between the DRF concepts. So maximum allocations of algorithm with surface on and denoted fairness valuable with the DRF versus on the drag range. So allocation fairness of DRF is within that of the using max minimum obviously when the DEFF model to according to the DRF can achieve the better fairness values and the using maximum minimum. The further will increase the under the variation of time. So demand the DEFF model can still perfectly provide the measurement and allocation fairness. So this is shown as the simplification of three languages running times in which establishes time variations versus the oriented in the fairness value and the sample points. So now we discuss about flow diagram. First users enter and then select the demand. The demand means in the enter the some files. User is allocate the task to the this sections. So users create the three users enter our IDs. So ID means based on the user full details. The details in first enter the user's ID. Likewise user's ID, name, age and then male or female. So that's all. So and then demand type sizing in the determination. This means when the users is some task allocated to this location. So file is based on the type. So which type of file we are choosing and then allocated and then collect the file size. So that size is allocated to the dynamic resource allocations. So based on the file size based on requirement and then allocate demand of size resource. So because file size is based on the demand allocation is reduced to the loading time and the computation of our service times. So we choosing the demand sections of a resource and the resource terminated and resource successfully allocated. So resource terminated means the file size is more than is based on the demand locations. So that files is removed then and then only used as the resource successfully allocated. This is final results. So finally we get the ending process. So resource successfully allocated then to the end and the resource not allocated, resource terminated, immediately go to the end phase. Now discuss about the demo. So first we click first page. This is a home page for this process. And this is cloud computations and then you just click. This is we create the user ID. So now I am create the user ID. This is 01. They enter the name, value, and then password is also same password is value and then click mail and then submit. So data successfully saved value and then browse some files. So now I am choosing cloud text. This file now I am choosing. So file successfully selected and then click the next second user. So this is second user frame. So now you click to, and then using the yogi. So password is also yogi. And click mail and then submitted. The data successfully saved the yogi details. And then yogi is now click some files. Choosing all spam text, spelling text. So click and then browse the file successfully selected, and then next, and then create another user ID. So the users enter this process. And click and then password also will store and then submit. The successfully stored, and then browse the another file is storing now. This file is also stored, and then click next. So now this frame is getting the user 1 to user 2, user 3 the details. So user 1 full name, file name, and then this is full path, the file length, and then get the user 2. The user 2 select the file splitting, the file path full as read path, and then file is length, and then get the user 3. So file name is description. This is also full name based on the path, and then file size. So demand the value of this is a calculation of this process. So user 1 demand the value is 0, the other is 0, another is something also 0. So this is not used in memory. So demand is very low. So and then the first issue is getting the used memory, and then click next. So second issue is allocation of memory. This is also same, and then next, and then to resource the body in the system identifying the best one. So which process the best one process? The first resource the best one process. Okay, now we click submit. So because demand A, B and C. So you store the successes. You see access success.txt set path and then submit. Then with the file is successfully submitted, and then next click. So second resources, second is submit of the same. So yes, you see as a successful dot txt. So this is also submit. Write the file successfully uploaded in the next file, and then click next, and then best resources also, and then fine, and then first resources. So now we're choosing second resources, submit, and then success dot txt save css success 2.txt. Now submitted. So resource not submitted, and then so using so submit. Now it is successfully updated. Thank you.